So my path to get here, it has taken a couple of turns too, although sort of all around the world of physics. I did undergraduate work in what's called condensed matter physics, studying the electronic properties of materials, how superconductors work and things like that. That's just what I happened to do, because I told you people kind of brought me into the lab. It wasn't like I chose that, it just happened. But because I did that, I figured that's what I would do. I would just sort of follow along the track. So when I was going to go to graduate school, I thought I would work on this kind of project. Then when I was a first-year graduate student, I taught with this thesis advisor that I mentioned to you before. And I really liked him, and he was doing this new thing. And it was a high-energy astrophysics experiment, looking for ultra-high-energy gamma rays from the sky. I didn't know anything about that, but I really liked this guy, and I liked the way he worked. And so I did that. I spent 6 years doing that, and I got my PhD. And then I had to think about where I would go for a postdoctoral position, which is a normal thing for regular science people to go straight into a postdoc. And I was married by that point, right? And my wife got a new job near a place called Fermilab, a particle physics lab. It was a really important job for her because she was moving out of a job she really hated and stuff like that. So I had to get a job at Fermilab. And I figured I could. I was a particle physicist. I could do something there. And so I got a job there, and they gave me a job that actually was a flexible postdoctoral fellowship. And this is a really neat thing that a lot of places do, and they're maybe doing it more than they used to. Kind of hiring young people and saying, just come here, and you work with anybody who's here on whatever you want. And that kind of flexibility, the reason places do it is because, number one, it lets them attract really good people. And second, most of the time, whatever those really good people want to do is what people ought to be doing. Right? They actually know better. So when you have a lot of these senior labs and they're saying, no, you have to work on my thing, a lot of times that's actually not the best thing. It's just some old thing somebody's been doing for a while. So anyway, they gave me this option, and when I started working there, they said you could work on whatever you want. And I looked around, and they were starting this new astronomy project, this Sloan Digital Skies. And it just looked so cool. And I didn't really know anything about it. I had never taken, in fact, I had still never taken a class in astronomy, a 101 or anything. I'm a professor of astronomy now, by the way. I haven't told them that I haven't taken a class. But I knew how to do some things they needed to do. I knew how to build electronics, and they needed a bunch of that. So I started working on that while I'm kind of boned up on the other stuff along the way. And it did turn out to be a really cool experiment, a really important, influential experiment, mostly because, like I said, we gave the data away. And that made its impact just be enormous. Scientifically, just fantastic impact. And then the reason I came here was because, of course, I always wanted to be at a university because I wanted to teach. And the University of Michigan, I was born here in Southeast Michigan. I didn't go here or anything, but it was just perfect for me to come back to the University of Michigan. So they actually came and asked me to apply. That happens. People get asked to apply. They look around for people they think they might want to have, and they ask you to apply. And we got the job here. I got the job here, so we came here. And since then, I still do a lot of work in astronomy, but I spend a lot of my time and energy on teaching things. I'm the director of the honors program, so you guys know that. On helping to run the university. Now I'm writing a textbook for this class that you're taking. So new things keep coming along that I'm doing. Doing a bunch of very interesting research on how students learn physics right now. Very interesting. I don't know if you would find it interesting or alarming that we can actually look at you at the beginning of a class and predict what your grade's going to be to about a half a letter grade. Wow.
What information do you need to do that?
Crystal ball.
You just the official.
No, it turns out it's amazingly easy, and I don't think you'll be that surprised when I tell you what the most important parameter is. It's your University of Michigan GPA before you take this class. Students who mostly get A's, mostly get A's. Students who mostly get C's, mostly get C's. And it becomes a pattern pretty quickly, and it extends typically across a lot of classes. So just take your University of Michigan GPA and it will make a very good prediction of what your grade will be in your physics class. Which is not fair. In your physics class, we have to knock it down a little. Because people typically do worse in their physics class than they do in the average class on campus. I think you probably know now it's a harder class than some of the classes on campus, right? So that shouldn't be too big a surprise. But it's really true. You can just take that and you can make a pretty good prediction of where people are going to be. So So the reason I'm doing this work is that I want to understand. So some people do much better than you would expect. Right? You know, you sort of expect them to be here and they end up here. Some people do worse than you would expect. I want to know why. Because that's the main thing, right? Everybody's going to sort of do as they're going to do. You know, if everybody could do better than you expect them to do, if we could figure out what you do to do better than you expect, then I would tell it to you and you would all do it and then everybody would do better, right? Maybe. That's kind of the hope. So we're doing these studies now to try and understand what makes the difference for people. And that's become a whole new intellectual endeavor for me. I have to learn how to get permission to do human subject research. Never thought I would do that. I study galaxies. And you don't have to have permission to study galaxies. There's no ethical questions about what you publish about galaxies, right? I have to learn how to do social science research, which is really, really different and complicated. People are not like galaxies, you know. They lie to you. I mean, you know, there's all this complicated stuff that goes on. They tell you what they wish was true instead of what really, all that kind of stuff. So intellectually, that's been a really fun part of being a professor, is that you get to work on all kinds of different things. And I don't know, that's really fun.
And I hear more and more people, like professors, saying that you know, I got in expecting to do this, and there's all these, like you're saying, it's all these new things that you get to do that never in a million years would have thought that you would be doing. And that to me is pretty cool too. Mm-hmm. That, you know, who knows where I'll be 10 years from now? What, you know, if once I get a faculty position, who knows what I'll be doing? And that's exciting to me too.
And, you know, I don't care what you go into. That's your life. I mean, I don't care whether you want it or not. Nobody's going to find a job and like sit in it for 40 years anymore. It's just not happening. So you're, whatever way you go, you're going to have a life like that, right? Where 5 years you do this and then things shift and they become different. There's a whole new set of tools, whatever. So that's the way life is going to be. Everything you learn here, you're not going to need to know. Except